Welcome to session 4 of the design series. We are covering domain-driven designs. And this time, we are going to go through a set of strategies that the author has proposed for the communication between any two bounded contexts. We'll continue with the same example we took in the last session. It seems to fit most of the examples. So, without any particular order, let's start uh, with the first strategy, which is basically the customer supplier interaction. Now, what it means is customer supplier basically your downstream, upstream. Uh, Here, basically, your supplier or the upstream has to model the contract or the interface according to your needs of your downstream service. It's like your customer or your downstream is the paramount, or the needs of the downstream are paramount for the supplier for the context of this interaction. Now, to take examples of like where you would found or where you might have found such interactions is like the first example would be a third party integration, which is in this case, this particular case. So whenever you are integrated with a vendor, right? Uh, Depending on like who is providing services to whom, let's say if the vendor is providing services to you, you'll find like the vendor would end up exposing endpoints for your needs a lot of times. Why is that? Because the needs of the customers are paramount in this case. So that's one example. Another example could be your general PL to your app interaction, not the Orion one, but basically wherever you do this kind of an integration, uh, your app team would tell you like they want a specific sort of a contract from the PL, and that is where you adhere to. So one takeaway from here is basically your customers' needs are paramount here, and that's how you model this. I've given you two instances where this might be used. Uh, should this be used in business to business service communication? That is where the next layer comes in. So customer supply strategy was more focused towards the customer's needs, as the needs, as I said, were paramount. The supplier or the upstream service had to make sure the contract adhere or the APIs adhere to whatever the customer wanted, and which would typically be used in your like client server communication, as in an app to your presentation layer or your third party integration. But for business to business communication, you wouldn't go with that sort of an approach. Rather, there's another strategy which is called the conformist strategy. Now, here what happens is instead of modeling as per what your client needs, you model the interface of your service or your bounded context in terms of what makes sense to that context or like whatever are your entities. To take an example, let's say you have an app screen where you want to show um, maybe an ongoing loan, which should have its own specs like current EMI, pending amount, etc. etc. Along with that, you want to show a table, which is like the history of the past loans. Now, and this is where like not specifically this example, but similar examples are where I had to like comment on my team's design also at times. What happens is when you're building a project, at times you have the full product requirements doc, you have the app designs, and you're making your backend accordingly. And one of the mistakes people end up doing is, as per their app design, they expose their service API. that, okay, I need to show the present loan also and the history of the loans. So maybe I make a generic API, let's say called the get loan details, which is supposed to do this magic. Uh, but what they forget is there's another layer in between, which is called the presentation layer, which is supposed to ideally adhere to the client needs. And that shouldn't be the case of your business service or your backend bounded context. So instead of doing that, you should model your APIs in what makes sense to you. Uh, just taking a random example here, like one API could be get loan histories, right? Another API could be get loan details, which or get ongoing loan details, let's say. And accordingly, basis this both APIs, like for the first one, you'll be querying this table. For the second one, you might be querying this table. But basically, you make an opinion on, okay, what makes sense as per my bond context. And accordingly, whoever is consuming your APIs, they adhere to those requirements. Okay, I need to show both of these. I'll call two APIs of loan service instead of asking loan service to give me a single API which solves for this screen use case. Um, Similar would be case with your if you even look at core services at UC, uh, they would have very opinionated APIs. At least, uh, like even if you look at customer side, provider side, or lead side, they would have a generic bulk API, a generic get API, and not very specific to a particular business use case. So that's the conformist pattern, which is most preferred for your backend to backend communication. So the learning here could be that instead of thinking of, okay, what does my client need for their use case? You think in terms of, okay, this is my service. What are the meaningful APIs I should expose from here in my interface? So that's the power of this overall conformist pattern. What else do we have? Let's cover that next. The strategy is, sorry, anti-corruption layer. It had a fancy name, but I'll start with the use case rather than explaining what it does. Let's say you are revamping your system. It could be any sort of a system. Let's say you are revamping it. You're coming up with the new entities, you are coming up with a new design, more opinionated. Let's say you're doing this domain driven design exercise on this loan system altogether. What would happen? You would have some existing clients which will have their own ongoing requirements, their own integration with your system already, correct? But you on your own might have your own new models. Like you might even end up changing the schema, like the very basic fundamental of your bounded context. So how do you deal with such a situation? Now that is where this anti-corruption layer comes into picture. Anti-C, let's call it this. So to explain this very simply, like imagine this layer as a mix of, now we are going back to design patterns also, as a mix of adapter plus a facade. So basically, you have your new service here, but your clients talk to your old service. But slowly and gradually, you want to migrate their clients to your new models, new schema. But that doesn't happen in a big bang. There's always a transition that would happen, right? So what you do is you place this anti-corruption layer here, Now, instead of moving all the bad since the old module might have, hence you are remodeling it, what you will do is you'll introduce this adapter layer to interact with your existing clients, and that adapter layer in turn interacts with your new models, new schemas. Now, whenever you are doing a refactoring, you will obviously not like get rid of a major use case. You might get rid of redundant use cases. There, it's easier. You don't need this anti-corruption layer. You might just go with this conformist pattern. But whenever there are big enough use cases, you'll have to have this adapter layer in between for that momentary transition to happen. Now, once like your new service is stable, etc., you have your new interface set up, that is when you go to your clients and say, okay, now instead of calling that API, can you please start calling this API? Now that in itself would be a big exercise. Or you at times, like if I take UZ's context, like what people end up doing is they go to the clients and they start creating MRs on their own instead of like waiting for the client to do the migration to help with the effort, overall effort and speed up the process. So that is what this anti-corruption layer is. So if I have to summarize these three strategies, you look at customer supplier, which is a recommended way to go for your third party integrations, your PL to your client integrations. Then there's a conformist pattern, which is your go to way for your backend integration, your business services interaction. Instead of modeling for the client, you model as per whatever makes sense for your ongoing context. And third is this anti-corruption layer. So whenever you're remodeling your backend, let's say, or yeah, so that's a typical use case for this. Whenever you're remodeling your backend, um, to adhere to existing requirements, you put this anti-corruption layer in between. You won't call it anti-corruption, you will call it a sort of an adapter. Uh, and yeah, that is the role of this adapter to basically interact with the new service, new models, new schema, and still adhere to the old requirements until you make the migration. So yeah, that were the three patterns we covered. There's another pattern being covered, which is what's a strategy rather. It's called a shared kernel strategy. It's not the recommended way for integration, so I wouldn't spend much more time on it. It is a basic way of saying basically there's some common code. Let's say, hmm, how do I put it? Okay, I think this would be a good example. Like imagine a world without this Orion and everything. You have your client teams, your Android teams, your backend team, and then there's a presentation layer. Now, which used to be the case very early on in UC also. So you had this presentation layer, which would be in your gateways. Now this code, um, imagine if it is partially owned by the client team and your backend teams also. Like some of the changes would be done with your backend team, some of the changes would be done with your Android team, let's say. Now this becomes a shared repository, correct? And both the teams, even though these are two different contexts, they'll be writing code in the same module at times. Now that's the approach which is called the shared kernel. Um, it is it is very process driven in the sense like because it's a shared repository, you can't make any changes before informing the other stakeholders as there might be breakages. So yeah, automated testing and rigorous testing, communication, everything is recommended here. Coming to automated testing, yeah, similar is customer supplier. Like here in this case, any changes the supplier has to make, the supplier has to be like very, 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 very careful about the customer's need, else things might go south. Conformist anti-corruption layer, it's like the control is more with the service owner. So it's up to them. They just have to adhere to the interface and all. So yeah, that were the four strategies. We'll cover more in the next session. That would be a live session, I would recommend. So yeah, thank you.